Okay, you guys finishing up the cards? Okay, so I'm gonna get started. Let's look at this pink salmon truce. What's this? Puce? What's the name of this? Puce? Let's go with salmon. Let's look at this salmon periodic table. So you need to be able to assign oxidation states. Now, they're a little different than charges, and you'll learn that if you continue in the sciences. But right now, we're gonna make it as simple as we can. Everyone can find group 1, yes? On the pink paper. Yeah. So everything in group 1 will have a +1 oxidation state. All the way down. Everything in group 1 is +1. Everything in group 2 is, what do you think? +2. +2. +2 all the way down. So what is the oxidation state of calcium? Hey.
+2.
What's the oxidation state of potassium?
+1.
Thank you. What about barium?
+2.
+2. Do we get it? So, now, is that written anywhere? Can you guys remember that? Cool. Now then, let's hop over to what's going on?
Wait, did you say calcium or potassium?
I said both.
Oh, okay. Okay.
So what's calcium?
+2.
And what is potassium?
+1.
Yes. So hop all the way over to 17. 17 has 7 valence electrons. So it wants 1 more electron to be happy. So in 17, they are going to form -1 cations. What's going on? What's 17 going to form?
-1.
See, not +1, -1. 17's -1. You got it. We're trying to learn a skill. 16, group 16 has 6 valence electrons. If it has 6 valence electrons, it wants 2 more to be happy. So that's going to form -2 oxidation states, or -2 anions. Get the earbuds out your ears, please. Get the earbuds out your ears. I don't know if you're listening to Freddy Krueger or you're paying attention, because I just don't know. I can't hear it. Freddy Krueger's not a nice guy. You guys even know who Freddy Krueger is?
I don't know.
Thank goodness. It's a monster. Is he a monster?
Yeah,
I'd say so,
he
yeah.
is a monster. Like the ethics, go into like ethics.
But he started. Oh, I see what you're saying. Yeah,
He's
gotcha.
a little.
Group 15, we got -3 down, right? Then group 14, we got +4 or -4. Right? These are our carbons, our tetravalents. And 13 +3, partially the way down. Now, what about everything else? Everything else, including this stuff down here, everything else, the information's not on the periodic table. You will get from the formula. When I say formula, I mean chemical formula. You're going to get from the ratio of elements and how they combine in the chemical formula. you're going to get from reverse crisscross applesauce. Okay? Now, so first thing, next little reminder. PO4 minus 3 is what? Phosphate, right? Phosphate. You were asked a long, long time ago to learn the polyatomic ions. SO4 minus 2 is sulfate. Now, NO3 minus 1 is nitrate. CO3 minus 2, carbonate. CN minus 1. CN minus 1 is cyanide.
Acetate.
CF. Yeah, acetate. OH minus, hydroxide. Right? So you need to not only know these, you need to recognize them, know their charges, and be able to spot them at a whim, right? So you didn't have to learn them just for the next day of the quiz. Now that you're baby juniors, these should be in your brain and completely retrievable at any moment. If they are not, get them that way, or else you will not be successful on this test or any future test. Okay, so get that on your to-do list, not to memorize, to know them. Luckily, we're going to use them a whole bunch, and that helps, right? That helps. So, oxidation states. You should have picked up a worksheet entitled Assigning Oxidation Numbers. Let's all be looking at that. It says, the first rule is that pure elements have an oxidation number of 0. So what's a pure element? If you have a hunk of gold, that's how you would represent it. So its oxidation is 0, and you place it above the element symbol. Not next to, you place it above, because that's where you place oxidation numbers. These are not the same as charges, right? They're not the same as charges. So that's a pure element. Cu is also a pure element. So what's its oxidation number? 0. So any pure element has an oxidation number of 0. Now, there are 7 other pure elements. Tennis balls. Tennis balls. Tennis balls. Tennis balls. What? The diatomics. So H2 is the elemental form. So H2, what's the next one? N2, O2, F2, Cl2, Br2, I2. In that order. How'd they get the order right? How'd they get that order right? Look at your periodic table. Put your finger on nitrogen. Put your finger on nitrogen. You know I can see your finger, right? Okay. Okay. And then, so that's N2. Hop it over one. O2. Hop it over one. F2. We're going down now. What's under F2? Cl2. What's under Cl2? And what's under Br2? I2. Now, where on earth is H2? All the way on the other side, right? All the way on the other side. All of these are elemental forms, so their oxidation state is 0. Okay? That is the first rule. The second rule is the oxidation number of an element in a monatomic ion. Mono means one, so a one atom ion. A one atom ion. A one atom ion. That is one atom, and when it is an ion, plus one, this is an ion because that plus one is in the charge position, right? Atomic number, mass number, charge, right? So what is the oxidation state on potassium if it's got a charge of plus one? Plus one. Not just one, plus one. It's okay, because this isn't directions on a number line. These are electrostatic forces, right? So it's not one, it's a plus one. It's a plus one charge. Do you see the difference? That's representing the ion. That's representing the oxidation state. Literally where you draw the plus one. Right? Literally where you draw the plus one. So another monatomic ion. There's an anion called oxide. What would its oxidation state be? And you'd put it up top, right in the center up top for the oxidation state. Make sense? Okay, cool. So let's go to 3. Rule number 3. The sum of the oxidation number of all elements in a neutral compound equals 0. So let's see. Neutral compound. Let's stick with something common, NaCl. What is the oxidation state of sodium, and how do you know? It is plus one, not one. It's plus one, goes in the center. How do you know? It's in group 1. Chlorine is minus 1. How do you know? Group 17. Now, you also know, because these are coming together in a 1-to-1 ratio. And sodium is always plus 1, so chlorine must be minus 1. So often you only have to know one, and you can figure out the other. What this is saying is plus 1 plus minus 1 equals 0. The rule is saying the sum of the oxidation numbers in a neutral compound is 0. So when we add plus 1 plus a minus 1, we get 0. And that's why they come together in this relationship. Let's look at calcium chloride. What is the oxidation state of calcium?
Plus 2.
Plus 2. Chlorine.
Minus 2.
No. Where'd you get calcium plus 2 from? Periodic table. It's in group 2, right? It doesn't change. It's not changing. If this is plus 2, it takes 2 chlorines to equal 0. This is plus 2, and it takes 2 chlorines to equal 0. What must chlorine be? Minus 1. How else would you know it was minus 1?
It's on the 2.
It's in group 17, right? It's in group 17 on the periodic table. I'm sorry? Right, so I need minus 2 here, right? I need a plus 2 and a minus 2, and that way I get 0. Make sense to everyone? Now, notice the 2 is not from the chlorine, it's from the calcium, right? And down here, there's a 1, that's not from the chlorine, it's from the sodium, right? Okay. Now, 4, rule number 4. Says the sum of the oxidation numbers of all the elements in a polyatomic ion equals the charge on the ion. So, what? Let's pick a polyatomic ion that we all know and love. What's this? Phosphate. We all love a phosphate, right? It says the sum of the oxidation numbers of all the atoms must equal the charge on the ion. So all of this is going to equal -3. And it's the sum of them. But we have two elements. We have phosphorus and we have oxygen. Okay. Oxygen is -2. How do I know that?
Because it's in group 16.
16. Oxygen is -2. And there are 4 of them. So I have -8 here. What must phosphorus be?
5.
Plus 5.
Not just, yeah, there we go. It has to be +5. So the oxidation state for phosphorus is +5. For oxygen is -2. There's 4 of them. Then all of this together is a -3 charge. Does that make sense? Yeah? Cool. Then 5, rule 5. It says fluorine is always -1. See fluorine, that makes sense. Groups 1 and 2 are always +1 and +2. Hydrogen, is +1 with non-metals. And -1 with metals. That looks like something you should probably memorize, right? It really helps if you're actively writing and engaged to stay awake. I get it. All of our blood is in our stomachs. I get it. We're trying to digest the food. We have got to force it up to our brains. You just got to force it. You just got to force it. It's happening to me too. It is. It's hard, isn't it? Sometimes it helps to slap your face. Give it a try. Anyone? Give it a try. Go ahead. Keep going. It's good. You know what really helps is if you slap someone else's face. No kidding. Don't do that. Don't do that. Okay, so let's get started. What is the charge of nitrogen in, what is the name of this? Dinitrogen trioxide. So what's the charge of nitrogen? And now notice there's no charge up here, so this is neutral. So all of these charges must equal 0. Oxygen is, yes, question?
Yes, but I can answer later. After you finish.
Okay, oxygen is what? -2. So what is 3 times -2? So -6 plus what? It's going to give me 0. Plus 6. Now, I have 2 nitrogens. If together those 2 nitrogens have to be +6, what is each individual nitrogen? +3. So up here we have +3 and we have -2. So what is the nitrogen in dinitrogen trioxide? The oxidation state of nitrogen is +3. Now, look where nitrogen is. What? That should be -3. Right? You're looking up there, it should be -3. It can have multiple oxidation states. Just like the transition metals. So that's why you're going to go with these rules. And the rules, oxygen is going to be -2 unless it's a peroxide, and you're not going to be dealing with peroxides this year. Okay? -2 unless it's a peroxide. So let's try the next one. We have H2SO4. Okay, what was your question before I get started on this one?
It was the N2, because I saw in the 5th rule that N would be -3.
The 5th rule N is -3 if it's the most electronegative element in the compound.
And
If it isn't, just use other rules to find its states. Oxygen, see where oxygen is? It's
more,
closer
yeah.
to fluorine. Yep. Yes.
Do you want us to write down the math like on the side or something? Do you care?
No,
Okay.
I don't care. So we're looking for the sulfur here, and it's neutral, so everything's going to equal 0. Oxygen is what? -2, and there's 4 of them, so this is -8. We got to add it to sulfur, and hydrogen is always what? +1 when it's with nonmetals. Is sulfur and oxygen both nonmetals? Yep. So this is +1, and there's 2 of them. So +2 plus what? Plus -8 equals 0.
6. Plus
Almost. +6, right? Does that make sense? So we have +8, -8, and that equals 0. Right? Okay. So how am I going to rate this? I'm going to put a little +1 up here. My sulfur is +6. My oxygen is -2. Right? That's when you put the oxidation. How are you taking notes if both of your hands are under your elbows and you're sitting back with your arms crossed? What about 3? Right? That's an element all by itself. Carbon can be all by itself, absolutely. Right? Graphite, diamond, all of that is just carbon by itself. Now, what about carbon in carbon monoxide? CO. What's oxygen? -2. So what must carbon be?
+2.
Must be +2. But wait, it's in 14. It can be +2. It can be +3. It can be +4. It can be minus. It can be 0. It can be a lot of things. Oxygen kind of determines it. So that would be, now, sodium in sodium chloride, +1. That's pretty easy because it's in group 1. Hydrogen in H2O, it's +1. How do you know? Because oxygen's not a metal. And oxygen's -2, so you would need 2 pluses for the -2. So there's multiple ways that you can figure this out. Barium in BaCl2,
+2.
+2. Different ways you can figure this out. Chlorine's -1, and you need 2 of them, so it must be +2. Or you look in group 2 and it's +2. Now, nitrogen in, what is this? This is nitrite. So we have NO2, the whole thing has a -1 charge, so everything has to equal -1. Oxygen is -2, and there's 2 of them, so that's -4. So -4 plus what? Gives me -1. +3, so nitrogen is +3 here. Oxygen is -2, and the entire thing is -1. Now notice you don't put the -4 up here, right? That's the individual atom. This you kind of do in your head. You don't put the -4 up here. Okay, so I'd like you to do 9 through 15 right now. We're building a skill. Don't blow it off. Excuse my slurping. This Yeti's been ridden hard and put up thick. Shoot. Forgot about it. Okay, what'd you guys get for sulfur, number 9? +2? Remember, the cation's always written first. Aluminum is +3. So S, oxidation state, -2. What about sulfur in hydrogen sulfate? +6. +6. Did everyone get +6? Did you try 11?
Yeah.
Yeah. What do you think it is?
-1.
Ooh. No. So we got Fe, and that is joined to some polyatomic ion we did not have to memorize, ClO2, chlorite, and it takes 3 of them. For every one of these. So, first of all, what does that tell us about the oxidation state of Fe? Anything? It might be +3. It might be +3. Now, it could also be +6 if this was 2 and it was reduced, right? But to be +6 is really kind of against losing 6 electrons. They would have just gained 2 to get to 8. See how losing 6 is not the fastest way to retirement? Right. So that means we can assume that ClO2 overall is a -1 charge. You could also look it up in the polyatomic ion table. Could have looked it up, but you can easily assume that 3 -1s will get rid of 1 + 3. You with me on that? Yes or no? Yes? So all of this together has to equal -1. What is oxygen? -2. And there's 2 of them, so -4. So what plus -4 is -1? +3. So the chlorine, what? It's +3. What? It's a non-metal. Welcome to life. Shades gray. There's no black and white. Shades gray. All kinds of things can happen. The possibilities are endless. The universe is a menagerie. Do you feel like you've been lied to? I felt very betrayed the more I learned. The more I learned, I'm like, wow, They did not tell me the right stuff. No? You guys are good? Yes.
Why is iron +3?
Where'd this 3 come from?
So that's the second one.
And there's a 1 here. So when it is a transition or post-transition metal, you're not going to be able to tell from the periodic table. You're going to have to get it from the formula. So it takes 3 of these. This comes together. There's no charge on it. You get the formula. So it's going to take 3 of these to get rid of that. Where does 3 come from here? There's a 1 written here, but we just don't show it. Right? We know that the cation comes first and the anion comes second. We know that the positive's written first, negative's written second. Right? Okay, so 12 made that easy. 13, what'd you get for nitrogen? Plus 5, nice. Copper
+2.
and zinc,
+6.
nice. Now, look at CH4. Hydrogen is always what when it's with nonmetals?
+1.
Don't guess. It's literally written.
This one.
Hydrogen is +1 with nonmetals. So this is methane. We all know and love methane, yes? So we have to equal 0 because this has no charge on it. So this is +4 for our hydrogen. So what must carbon be? -4. What? You said the cation's always written first, but this is organic chemistry. It is perfectly fine to write that. But this is organic chemistry. Remember organic chemistry when we're talking hydrocarbons? So we write it according to its structure. Right? And that tells us this. The central atom is the one written first. Right? So there's all this little nuances going on. Would you wake him up? The rest of us are here struggling to stay conscious because all of our blood is in our stomachs. We can barely hold on to reality right now. We're all half hallucinating. You can't curl up and go to sleep. That's what the rest of us want to do. Sit up. That's it. Nice. Okay, so why don't you guys do 17, 18, and 24 right now. 17, 18, and 24. See if you got it. See if you're ready for the quiz. Any questions on these 3? NO2 has to equal 0. This is -4. Plus what? This must be +4. Means this is +4, and this is -2. And then SO3 -2, so it has to equal -2. So -6 plus what gives me -4. Yeah, and then 24. H2S. That's with a nonmetal. So this is +2. Has to equal 0. So this must be -2. Yeah. It's just like H2O. And oxygen's -2. Sulfur's right under it. It's also -2. It's in group 16. Works on so many levels. Okay, next page. You picked up our second skill. Second worksheet. You will please do not do the back of the first worksheet. You can finish all the others up through 30 for homework, but do not turn it over. Do not do the back. Do not do the back. You are going to now focus on the second worksheet. Couple things you got to do. You got to predict the products in words and in formulas, classify the reaction, and balance the reaction. So we're bringing it all together. We're starting to be baby juniors. So magnesium bromide. Magnesium bromide and chlorine is what we're given. What is the symbol for magnesium? Use your new periodic table. Mg. And what is the symbol for bromide? Br. Now, what ratio do they have to come together in? The only way to know is look at their oxidation numbers. Magnesium is +2 and bromine is what? -1. How'd you know? Are you a genius? 17. So if this is -1 and this is +2, how many bromines do I need to make 2? I need 2 of those, 2 -1s for this +2. So it becomes neutral. Chlorine. What's the symbol for chlorine? Wrong.
CO2.
Thank you. Cl2. Come on, guys. We just did it. We just did it a few slides ago. Yes, sir.
Wouldn't adding the two change the name of it?
Wouldn't adding the, no. This is a type 1 metal, ionic. Do not get it confused with covalence. There are no prefixes here. There are no prefixes. There are no Roman numerals because it is a type 1 metal. Right? So you got to remember Unit 3 when we learn naming ionic compounds. Right? And don't forget these. Now, these two are going to react and switch places. This is a single replacement reaction. What is going to switch places? The bromine and the chlorine are switching places, right? So we're going to get MgCl and bromine. Ding, ding, ding. Also diatomic. Yeah, hold on. I'm not there. Is this the correct formula? Why not? What? Okay, you do not need this frickin' 2. You do not need that 2. You do not need that 2. What is the oxidation state on magnesium? +2. And what about chlorine? -1. So how many chlorines do you need? 2. Not because there's a 2 here. You will get it wrong if you copy the subscripts. You will get it wrong. Not because there's a 2 here, but because when chlorine meets up with magnesium, it has to do it in a 2-to-1 ratio. Right? Has to do it in a 2-to-1 ratio. Now, so what is the name of this? No, there are no prefixes. It is not magnesium dichloride. When do we use prefixes? Covalent. So that's all the non-metals in the corner. right? Magnesium, we're talking group 1, that's a metal, it's ionic. So we write the name of the metal. And we don't need Roman numerals because it's 1 or 2, right? It's not a type 2. And then the second element ending in "ide." It doesn't matter how many there are here, right? So it's magnesium chloride. And what is the name of Br2? Bromine, right? No special ending. It's not bromide because it's not the ion. Ions end in "ide." It's just the elemental form. So right off the periodic table, it's bromine. Hey, you guys want to do another one? Hell yeah, you do, because we got to do these, and this is you need to know how to do this for the rest of the year, because everything this is going to be, you're going to be expected to know this just to start your problems. Okay, so it says here we have aluminum and iron 3 oxide. So, anyone know the symbol for aluminum? Al. Okay. And their plus. Iron, Fe, oxide.
Oxygen.
That's oxygen, so that's a capital O, right? Now, those are the 3 elements that we're using. We need to find the formula for this. What do we know about oxygen? It's -2. If we look at iron, it's a transition metal. It's a type 2. That's why it has Roman numerals. It's type 2. We can't find its oxidation state from the periodic table. It was given to us in the name. So this is +3. So that means I have 3 of these and 2 of these. Right? We're making 6. Single replacement. Is the iron and aluminum going to go together? No, because they're both metals, right? That would both be cations. So what is going to go together? The aluminum and oxygen. And then what's going to be by itself? Fe. So now we have to look at aluminum and oxygen. What do we know about oxygen? It's -2. What do we know about aluminum?
It's +3.
It's +3 from being a 13. So we're going to put a 3 here and a 2 here. Yeah? So then we have to balance. I have 1 aluminum here and 2 here, so I'm going to put a 2 in front. I have 2 irons here and 1 here, so I'm going to put a 2 in front. 3 oxygens, 3 oxygens. I'm good to go. There's my balanced. And this is a single replacement reaction. So then what is this called in words? Aluminum oxide, not aluminum 3, because it's not a transition metal. It's in group 13 and everyone knows it's +3. So this is just aluminum oxide. And, I'll just do a plus sign. What's Fe called? Iron. Now, is it iron 3? No, because it's by itself. It now has an oxidation state of 0. So you're not going to keep the Roman numeral with the name. It's just iron now. Isn't this fun? Want to do another one? Okay. So, this is a good one. This is a good one. I'll start a new page so it's up high for my people in back. We've got silver nitrate. Silver nitrate. And we're adding it to zinc chloride. Let's just do the words first. Outer, inner. We're going to get what? Silver chloride. And what? And zinc nitrate. Yep. silver chloride and zinc nitrate. See how we could just do it with the words? So first, silver is Ag, and we memorized nitrate. What was nitrate? NO3. Now, what's the charge on NO3? -1. And what's the charge on silver? Okay, silver you have to memorize. If you remember, which I guess you don't,
Oh, it's mine.
aluminum is +3. Diagonal to aluminum is what? Does anyone remember what that one is? +2. And diagonal to zinc is silver, +1. So zinc and silver are transition metals, but you don't use Roman numerals because they can only have one transition state and the whole world knows it but you. Okay? So you need to learn this so the whole world knows that you are now part of the group. Right? So that's why this isn't silver 1 nitrate. That would be wrong. It can't be anything but 1. So this is the proper formula. Silver's +1, nitrate's -1. That's how it comes together. Now I kind of blew the cookie right here because zinc is symbol Zn, chloride is Cl, but zinc is always what? +2. The whole world knows it. So how is this going to come together? What's the formula going to be? ZnCl2, because chlorine's -1. And then now we have to write silver chloride. Well, silver is Ag, chlorine is Cl, and then we have to write zinc nitrate. Zinc is Zn, and nitrate is NO3. Now let's double check using oxidation states. Is this the correct formula for silver chloride? Yeah, because silver's +1, chlorine's -1. Is this the correct formula for zinc nitrate? No. Nitrate's -1 and zinc is +2. So it needs to hook up with 2 nitrates. It needs 2 -1s for its +2, right? This is +2. It needs 2 -1s to become neutral. So this 2 came from the zinc. That 2 came from the zinc. Now, let's look at balancing. 1 silver, 1 silver. 1 nitrate, 2 nitrates means I have to put a 2 here. Then I have 1 zinc, 1 zinc. 2 silver. Oh, I got to put a 2 here, and then so it's 2, 1, 2, 1. 2, 1, 2, 1. What are we thinking? What are we thinking? Pretty awesome. And what type of reaction is this? It is a double replacement or double displacement, any way you want to say it. But let's double check. Is it neutralization?
No.
Is it an acid and a base yielding salt and water?
No.
Nope, there's no water over here. Neither one of these is an acid or a base. So it's definitely a double. Definitely a double. Ooh. We're gonna look at 4 real quick. Cobalt 2 carbonate. Cobalt 2 carbonate. And then it just has an arrow. So what type of reaction would this be? Decomposition, right? When you have one reactant, it's going to break down into the parts. So this 100% is decomposition. Let's see what it's going to break down into. I'm pretty sure we're going to get cobalt by itself. But first, the symbol for cobalt is CO. And what is the formula for carbonate? CO3. Carbonate is -2, and this tells me cobalt is +2, right? It tells me its oxidation state. So that would be the formula for cobalt 2 carbonate. Yeah. So that's going to break apart. Well, it's going to split apart, and we're going to have cobalt all by itself. Now, Here it was +2. Is it still +2?
No.
No, now it's 0. So when we write the word, we don't say cobalt 2, we just say cobalt. Cobalt and, well, what do we have left? CO3. But what's going on here? Is it -1? Why are you guessing?
Nice.
It has to be -2. Remember, this was +2. This has to be -2. They came together in a 1-to-1 ratio. This one's no longer this, but this is still -2. So we get cobalt and what? Carbonate. Decomposition reaction. What do we think?
Wait, so why did it like lose its charge, cobalt?
Because any element by itself has an oxidation state of 0. Now it's just a hunk of cobalt metal, right? Just hanging out by itself. So please do 5 and 6 all by yourself right now. Yeah. Yeah. You may get water. And then come back and do 5 and 6. What are you doing? What are you doing? You what?
Huh?
What are you doing?
It's types of reaction.
But that's not what I asked you to do. I asked you to do 5 and 6. What? Yeah. Put that away. Thank you. Put it back in the folder so it doesn't get all wrinkly. Stay on target. Stay on target. Rebel Alliance is counting on you. Stay on target. Stay on target. It's a shame that guy got blown up and killed, right? What ones are you doing? 5 and 6, right? How'd you guys do on number 5? Everyone get ZN for zinc? Please say yes.
Yes.
Okay. And then it gave you the hydrogen chloride or hydrochloric acid. So it gave you the formula for that. Zinc is a metal, traditionally a positively charged, right? So it's not going to hook up with hydrogen, another positive charge, because like charges repel. So it's going to hook up with chlorine. Does that make sense to everyone? So it's going to hook up with chlorine. Hydrogen, is hydrogen going to be all by itself? Well, diatomic, but yes. Yeah, don't forget it's diatomic. And then how did I know that there was a 2 here?
It's only -2.
Chlorine's -1, but zinc is +2, right? Zinc is +2. So I had to crisscross applesauce. And then what type of reaction is this? Single displacement. Single displacement. Basically, our cations are switching places, right? Our zinc and hydrogen are switching places. Yes.
Can you explain the difference between replacement and displacement?
Potato and potato. It doesn't matter.
Oh.
You could say single displacement or single replacement. That's why the notes had both words. What's the symbol for hydrogen? H. And what's its oxidation state? +1. What's the formula for sulfate? SO4. And what's its charge? -2. So how many hydrogens are needed? 2. So it's going to be H2SO4. What is the symbol for sodium? Na. What's its oxidation state? +1. And hydroxide. It is OH, and it's -1. So it's going to come together in a 1-to-1 ratio. Now, outer, inner. So outer and inner. So we're going to get sodium sulfate. And hydrogen hydroxide. Yeah.
Does it matter, like, if you put the hydrogen hydroxide first?
Nope. It doesn't matter. But hydrogen hydroxide is, anyone? Water. Yeah. Hydrogen hydroxide is water. We look here, outer is our H and our OH. It's going to make water. Inner is our Na and our SO4. So we're going to have our Na and our SO4. Sodium is +1, SO4 is -2. So what does that mean? I need 2 sodiums for the sulfate. And then when I have OH and H, talk to me. That's my H2O. Now, is this balanced? No, there's 2 sodiums here and only 1 here. I got to put a 2. So I have an H and an H, an OH and an OH. So how many waters are over here? 2. Right? Because that's going to come together, that's going to come together. So that balances this. Now, what type of reaction is this?
Neutralization.
It's a double displacement. Then you check, it is neutralization. Double displacement, you double check. How do you know it's neutralization? Well, we got water, an acid, and which one's,
I was going to ask about the top one. That's the on the floor. The question before.
what about?
So that, do you not need to balance like HCl?
You got to put a 2 here.
Okay.
I wasn't doing the whole thing for you.
Yeah.
But the OH is your base. So you have an acid and a base making a salt and water for your neutralization reaction. Now look at 8. What type of reaction is this? Combustion. So we have C9H20. It says nonane, so we know it is all single bonds, right? Series of 9 carbons and 20 hydrogens. This is a hydrocarbon added to oxygen. Will always make CO2 and water. Always going to make carbon dioxide and water. That should be memorized. If I go to balance it, I have 9 carbons here. I've got to make 9 carbons here. If I have 20 hydrogens here, this is 2, I've got to put a 10 here. I save my oxygens for the end. 9 and 2, this is 18, and 10 and 1, this is 10, for a total of 28 oxygens. What would I have to put in front of O2 to make it 28 oxygen atoms? 14. So we're looking at 1, 14, 9, 10 to balance it. And hopefully you know the name of this. Carbon dioxide and water. You can just use water. You don't have to do dihydrogen monoxide. You can just use water. And you balanced it, and the type of reaction is combustion. Type of reaction is combustion.
Wait, so we can just write H2O?
Mm-hmm. 4 number 11, you're going to use lead 4. Look it over, number 11. Look what group lead is in. It's in 14. So the most common oxidation state for lead is going to be +4. Because it's in group 14. Okay, so you want to finish this up during class. You need to get really good at predicting products. So you want to finish this worksheet up. Take it slow, follow the method. Has anyone already finished?
Front and back.
Huh?
Front and back.
Front and back? Have you finished front and back?
No.
Okay.
That's why I'm surprised.
I was just wondering if anyone, a lot of times people work ahead. So you are to finish this up. I have a meeting with the school board in a few minutes, and I need to get my questions ready. Have any questions for the school board? Like, why isn't MS Office free anymore?
What's MS Office?
Because it's all moppy it up. I agree, schooling.
The rice, it's so bad.
But rice, no, because rice is the reason for most foodborne illnesses. There is something called Clostridium perfringens that very quickly will grow in rice. Any rice that's not kept at a high enough temperature, because it's actually on a grain of rice, and it completely makes it through the steaming process. The spores germinate, and it causes explosive diarrhea and vomiting and nausea for about 24 hours. So it's the number one foodborne illness cause is poorly prepared or maintained rice. Clostridium perfringens. And so to be able to serve rice like in a cafeteria for 4 hours long, they're going to put all kinds of crap in it to keep that bacteria from growing. So you never want to get rice out like that, right? You just, It is, I mean, it's bad. Globally, Clostridium perfringens. What?
Yeah. So for that one, the other side.
That's not the problem.
I don't know.
You know this. Have to figure out how to do this, or else the rest of the year will be following us. And not because of me.
I mean,
No, no, they are not both for one. I specifically said do not do the rest of the oxidation worksheet.
Did you finish that?
Because I did not know I was having.
Yeah.
I guess it's okay.
But I
We would rank or would it be
Potassium iodine is just Ka trying to take I to because K is plus 1 I is minus 1.
No, that's only one.
Is ammonia? Oh wait, ammonia? NH3, right? 3 plus. Plus.
plus 2?
You said plus 2, plus 1. Plus 1.
No, it's
NH3 plus 1. Maybe it's plus 2. I got it.
And, oh, I have it. NH4 plus 1.
4. NH4 plus 1.
You kept saying AM. You said AM.
AM.
Yeah, AM.
Come on, you're a baby junior.
Oh.
Make your
With
own.
A. Wait, would this be?
Make
Wait,
your own.
it's NH.
If this is
What was it
two,
saying? What was I saying?
would you like?
Maybe I was just not saying the right words.
Because remember, covalence use prefixes. Ionics uses type 1, type 2 metals. Type 2 have parentheses.
What are you gonna talk to the school board about?
Minus 2.
It's a very good question. Here. A very good I'm going to use the virtual back to school night as an example. So, pandemic, we went virtual. So the previous back to school nights we've done virtually. Teachers make videos for each of their classes and parents can look at them whenever they want. And now we're going back to in-person back to school night next year, right? However, parents want both. They want in-person and virtual. Well, it takes about 3 hours to make one of the videos per class. So you don't get both because they're not paying us for both, right? Before COVID, you either taught online or you taught in person. You didn't do both. Now, because of COVID, everyone wants both. People want recordings of the class, right? They want this individual stuff, but there's just not enough time because it's working 2 jobs, right? I can't host electronically and prep labs. I can't teach in person and online at the same time. So the fact that they're going to now ask teachers to do that because parents want it is just one of many reasons why teachers are leaving the profession in gobs. Even Woodson, a desired school, has openings that we can't fill. We can't get teachers in. After school time, most teachers are staying past 6 or 7 o'clock at night just to get their work done. That's insanity. It's 14-hour days. The county's late policy is hurting more students than it's helping. So the late policy started because of COVID, and we're not dropping it, right? It's kind of like you made all these rules out of panic, which is good, but you gotta slowly pull them back. Because the fact that I can't go over materials with everyone else because a few people are doing it late just hurts everyone else. The only way to fix that is if I make different versions. So then a teacher has to make multiple versions for being late, taking a quiz late, for any of that stuff. Parent communications. Email is pretty much hate mail for teachers at this point. You don't check your email, you check your hate mail. And maybe that's because of social, I don't know what that is. But the number of just really mean emails to teachers from parents and students is skyrocketed. And it might be because of social media, and students can say mean things on social media, so they think they can say mean things to teachers. But like in a year, you're going to need teachers to spend 4 hours writing you a letter of recommendation so you get into university. So have you been?
By all emails being recorded, any email can't be sent to like college.
That's just more work. That's a job, right? And then you're just kids, right? You're just kids, but kids need to learn what to do correctly, so you're not chewed up in 2 years when you're out and about on your own. Well, not really on your own, because I'm sure your parents will still take care of you. There's a lot of stuff. There's a lot of stuff. You asked.
I was curious. I grew up in a different district, so I was wondering what is used teacher space here.
And they just took away our health insurance and gave us a substandard health insurance. So
You guys have health insurance?
Why is this carbon? And why is this one not?
I'm from LA, so
they have health insurance in LA.
I'm pretty sure.
Yeah. So
I don't think I have that here. Oh, but I still must. This one is.
No, I'm just myself.
You know what direct?
I can't say. I'm not thinking.
synthesis. It's a synthesizing.